Well, next up, we have Bob Gelmacher and Steve Sherrill and Portable Power Supplies.
Yeah, this is going to be a two-part talk. And thanks to Steve, and Steve and I talked quite a bit, he was fostering the idea of trying to come up with an easy way to power our layouts when we go to shows and we go to micro meets and things like that. And you get a click here. When we go to these meets, there's a couple of questions I think we all have as soon as we get to the meet. First one is, where are we going to set up? And that all depends on the venue and the folks that are running it. The second is, do I have power? Because most of our layouts are going to need power. And the third, which is probably the most important, where are the restrooms? Anybody that travels, a couple of hours to get to one of these meets, I think the restroom might actually be the first question they ask, but I just thought I'd throw that in there. But as far as the power goes, that's where this presentation comes in. And this little device is a device that Steve found on Amazon. And it's a very small device. The board itself measures about 2 inches by 1.25 inches. And of course, it's a little bigger because it has the potentiometer here. But it's basically a motor speed controller. And it can work over a number of voltages, 6 volts, 12 volts, 24, 28. It can take up to 3 amps or deliver up to 3 amps, which is probably more than enough current than almost any of our layouts need, our smaller layouts, especially the ON30 and the ON18. And the other nice thing is not only can control the speed, but you can also reverse it. And that's exactly what this black glob here is nothing more than a switch that connects into the board and helps you to reverse. The potentiometer just has a couple of functions. Number one, it can control the speed, but it also at the far left throw actually is an on-off switch. There's a little LED that you can see right here. And as long as the board isn't enclosed by anything, you can see that LED fairly quickly. And on the end, there is this green plug, and the green plug is basically where you provide power to this device. The two that are on the right side are the power in, and the two on the left are they call them the motor out, which is the output that would go to our tracks. Here's the ad that we found on Amazon. I know when I bought them, this is even cheaper than I got them for. I got them for like 2 for about $10. And they're readily available. There's a number of manufacturers or a number of brands that come out and they're basically the same thing. And they're all, of course, coming out of China. The wiring is extremely simple on this. The only thing that you have to do is provide, number one, some kind of a power supply. And most of the time, I think a 9-volt battery would do the job, although you could put in 12 volts if you wanted to, and then run wires out to the tracks. That's all that you have to do with this. Even though this shows wiring here, this is the switch that comes pre-wired, and it just plugs into a little socket that's actually in the board itself. I mentioned, or I didn't mention, but this device runs on a pulse width modulated scheme. And by that, it's not the traditional potentiometer that's putting out various levels of voltage. It's actually taking that main voltage that's coming out and dividing it into pulses. And they call them duty cycles. And during any given time frame, the shorter that pulse is, the slower the engine's going to run. Because in this period right here, or this time frame, there's no voltage actually going to the engine. But because it's happening so quickly, and it could be up to like 15,000 cycles per minute, or per second, is that our railroad, our engines don't really notice the difference. But as you start to crank up the potentiometer, the pulse width, as you see here, gets wider and wider and wider, and it approaches the full power output. One of the things that Steve asked me when we started talking about this was, how do we package this? Because he found that having that board by itself and the switch on the board just was awkward. So we put our heads together and we said, could we build some kind of a box that these little power supplies would go in? And this is the resulting box. These boxes are about 4 3/8 by 2 5/8 by about 1 inch thick. These are 3D printed. And this is what the basic bottom line looks like on the box. Here's the reversing switch. Here's the potentiometer. And one thing that I added, which is this LED here, the LED is wired directly into the output and has a little resistor on there so that when the device is in the, let's say, the forward mode, the LED shows green, and when it's in the reverse mode, it shows red. The LED that's actually incorporated into the board itself, it was difficult to actually bring that up onto a surface. So in all of these faces that we printed, there's a little hole right here, and that looks right down into the LED. So you just have to turn the box a little bit to see the red LED, which indicates that the power is on. On the back side, and because we've originally designed this for a 9-volt battery, there's a little cover that pops off, and the 9-volt battery can fit in there, and then the cover pops back on. And it's held together with 4 or 5 different screws, as you can see here, and it fits nicely in the palm of your hand. Here are the components that made up the box itself. The top panel and the bottom panel, and here's the door that goes over the 8-volt or 9-volt battery. If one wanted to run this with a 12-volt wall wart, they could do it. And what I would do is I'd actually take and put another hole in the bottom here and put another jack, and that's how we connect in. I'll show that in the next picture. And this jack is right here, as a matter of fact, 2.1 millimeter barrel jack. And another jack could go in there, and you could plug into the bottom with a 12-volt plug-in wall wart, and it would work just fine. This is a picture of the internal wiring. It looks a little more complicated than it actually was because we added that additional LED. But normally you would just have this green connector here with power coming into it from the battery and the power going out to that jack. I'm going to turn it over to Steve now, and Steve is going to talk about some actual applications of this and other similar devices that he's found online. And like I said, there's a lot of them out there. They're all fairly inexpensive, and it's just an easy way to carry power around when we go to the different shows. Steve, do you want me to switch your slides while you talk?
I think, Tom, you have my slides, don't you?
He has the same ones, I think.
Oh, he does? Okay, that's good.
Yeah.
Oh,
Just tell me next when you're ready to go. Go ahead, Steve.
Okay. Well, I'm sure I'm glad I turned a lot of that over to you, Bob, because you're the technical wizard. So now we're going to go into alternate power supply for dummies, okay? As you can see right here, I was introduced to this by a modeler named Tom Boulder, who I met at the meet in Harrisburg. And I had taken 2 of my micros there, and come to find out that I didn't have but 1 extension cord. Therefore, I was only going to be able to do 1. But since Clem Ojevich was beside me with a more unique micro, he plugged his in, and I had my micro was not operating the whole weekend. So we're just sitting there. And I said, well, that's not going to happen again. And Tom Boulder had his display, a very unique display, which we have other pictures of. And so he came over and we were talking. He said, I went online and I got this picture right there of the power supply off of Amazon. And so I said, look, when you get home, here's my email address, send me the information. So with that, I went online and we came up with the supply that Bob just talked about. So next slide. Here's Tom Boulder's example of his micro. And if you see, it's in a very nice online dispatch. And it's written by Ian, what's his last name? Ian Holmes is the editor. And in this article, he tells how he built them and also how he mounted the controller. and he had a very unique way that he mounted this. So if you go to the next slide. Now here is the world famous test track that I talked about on New Tracks. Now, being that Bob had already said that it was a lot of work to build a case and you know, to make it so it would work in what I wanted, I said, well, there's got to be somebody out there who's making one already made. And so I went back on that Amazon site again and looked up PVM controllers. And lo and behold, there was this that you see in the picture. This is a completed, the same contents on the side, the same guts as we showed with the bear model. So go ahead and show the next one. Here's just another view of it, and I've got another loco on there. I've been running back and forth. Now, the case that this comes in is about the size of the blue boxes for wall electric outlets. So imagine that is the same size. It's 3.8 by 3.5 by 2.3. So what it does, what you can do with it, is you just put a screwdriver in the sides and slide this whole thing out. And as you can see, you had two ways to do this. You could either put the 9-volt battery inside, or you could mount it outside. And I've got a little pigtail there with the connection to the 9 volts. So, and what I have done now is I just keep it on the outside. It did not go and do any wiring on the inside. When you wire these, it's very easy because they put plus and minus and tell you where the positive and where the negative is to the motor and also to the power. So it's hard to make a mistake on that. Okay, next one. Here's another view with the 9-volt battery sitting out. You can see there's plenty of room in there, and it literally just slides up in there and clicks. Next slide. So as I've said before, everything is plain and simple. You can put the power with the plus and the minus so you don't get any shorts, and the motor plus and minus. Okay, next slide. Here's the face again. Now, again, this is the on-off. So when you turn the potentiometer on, you'll get a click, and the LED will come on in red. It does not increase in lighting. It just stays on and it's red. All right. Now, what I did, I put a potentiometer on this particular 9-volt output on this controller, and it did not lose any power except when it got way down in the 20 range. It was a full 9 volts all the time. Now, the other one that we did that was like Bob put in the box was I had 6 volts. Excuse me, I had 4 volts on that with a AAA battery box attached to that. And that ran the ON18 models at a wonderful slow speed. And it also, when I put the voltmeter on it, held as 4.5 volts. So next here again, this is the side view. And so it's, again, clear as day, plus and minus on the motor. This picture is just to kind of give you the size. Okay, next picture. Now, here's what I did. When you go to this site, you're going to get a lot of things that are offered to you. You just have to keep leafing through until you get to what you want to pay. So they have some for $15 each, $18. What the difference is, I don't know. I'm not a technical person. But when it got down to here's 2 for $20, so that's $10 a piece. Bob told me that he could not make one after purchasing the unit for that kind of money. So, this is the way to go. I believe if you want to have a finished look, and it's a nice, clean looking fascia. And I mounted it on my test track here with just one screw. All right. And I pre-drilled the screw, so it's went in there nice. And I didn't take any chance on splitting the plastic enclosure. And again, the forward reverse is on there, and it's really easy to operate. So now I got mine for $15, two for $15. So we're talking about $7.50. And again, you keep going through, and they have all kinds of electronics on that PVM control site that are not necessarily the PWM controllers. They have other things going on there. Look and maybe there's something else you see that you like. Next slide. Here again is the back of it. Again, it'd be very difficult to have a cross wire for the plus and the minus are short. You have to, Okay, next slide. It's a real clean looking controller. Next one, please. So here these prices go all over, okay? Now I paid $6.99 for the one I had, and supposedly it was 20% off or something. Here they have two for $8.99. So that's, $4.50 a piece. You can't get any cheaper for a controller than that. So here I am mounting it on my test track with the battery box hooked into that's just for the display. Okay. And that's basically the setup that you have. And it was real simple with the three AAA batteries in the box to set that right on top and put a rubber band around it. And you had something that's about 3/4 the size of a pack of cigarettes, if you can remember what that size was, since you not many of us smoke anymore. Okay, next one. And here, I think Bob has shown a picture of this same thing again. Now here's Tom Boulder had this is one of the ways that he installed this. Was real simple. He just put a piece of wood in, notched it on the side, and mounted the other things on the outside of the wood and hooked it in. So it was hidden. It was easily accessible. And he put the 9-volt battery behind the controller, so he could just take it out when it ran out and put a new one in. Really simple construction, out of the way, easily accessible, and hidden from view. And thank you very much.
One thing I'll add in there is, I looked at the difference in prices and was just trying to figure out why. And the unit that I showed and the last couple that Steve showed, the reason why the prices are so inexpensive is I really think they're using very, very, very inexpensive, quote, cheap components to make that. I had to try to work with the LED on one of them, and the trace, which is the copper wire that's actually on the boards, the trace is so thin that it comes off very easily. So I would suggest that you spend a little more money and try to get a little bit better quality unit. I don't think they're going to break very easily, but you do get what you pay for.
You think the enclosure was a better? Obviously, you have more protection with the enclosure.
I think it depends, Steve. If you want something that's handheld, and most of the time you wouldn't be walking around with it anyway, I think something that you can mount right there on the layout like you've done is probably what most people will wind up doing.
Yeah. Well,
yeah. And I like the look of the one that you showed better than even the one that I built. I think it's a more professional looking box.
Well, in that dispatch magazine that you see, a lot of the guys are doing this. They're having the on a cord, I guess, so they can operate the trains in the front, stand there, or have other people do it. But you know, very easy to operate, and they have very low control. I mean, you can run these locomotives real slow. It's amazing how for $4 or $5, $10, you get a controller like this that it may be as good as some of the transformers we have.
Yeah, I heard that you know, you could probably power this with a 12-volt car battery. It would last you 250 years.
Yeah. Pull your car up inside and put jumpers on it.
You know, what's really amazing is the Pico Flex Track on your test module is more expensive than that entire controller.
Including the battery.
I mean, think about that. That's just bizarre. And the price of these electronics is just mind-boggling inexpensive, you know.
And if you go to PWN controller, it will get you access to all that we've shown tonight.
Yeah.
Other things that if you want to look. And you know, that's Google. And I got mine within 2 or 3 days of ordering.
Bob, one technical question.
Yeah.
So you guys are using them for the relatively low amperage requirements of ON18. But these things, I mean, you could hook a car battery up there. And what if you had a locomotive that drew an amp or a half amp? Would it catch your house on fire, or would it work?
Aren't these good for 3 amps?
They say they're good for 3 amps. I've read a couple of the reviews. One in particular said it was good for 4 amps, but somebody said that they were measuring it and had it up to 1 ampere, and it was getting warmer than they liked. Again, it's all a matter of the amount of money you're going to put into it. I think when Steve pulled his box apart, there was a couple of these heat heat shields.
Heat sinks?
Heat sinks. Thank you. And you know, on the one that I have, it only has a small heat sink and it's loosely attached. Again, the more money that you buy, the better quality it's going to be, or more money you spend, the better quality it's going to be. And things like the ability to provide more current is built into that type of thing, you know, when you spend more money. But yeah, I mean, a 12-volt battery is not going to, when you hook it up to an engine, it's going to go forever. I mean, it's current carrying capacity is very, very large, and you're not going to run it out of gas anytime soon.
Well, that was a fascinating presentation, and I thank you both. And are there any final questions for these two while we have them on? Well, thank you both, and we'll see you next time.